Okay, so in this video, we're going to talk about the empirical formula and converting it to the molecular formula. So, real quickly, let's go over what the molecular formula is again. Alright, so your molecular formula is pretty much the true amount of each element in the compound. True amount of each element in the compound. Okay, and then we look at our empirical formula, and we remember the empirical is just the simplest whole number ratio of the elements in the compound. So, example, I'm going to just use one that I used in the previous video. We have our molecular formula of glucose, which is going to be C6H12O6. I'll write down glucose. And then our empirical formula, we're just going to look for the largest number that will divide into these, which happens to be 6. So we're going to get 6H2O, or CH2O. That's going to be our empirical formula. So it's the smallest whole number ratio of all the elements in the compound. Alright, so to convert between empirical and molecular, we're going to need the approximate molecular weight and the empirical formula. So usually when you're solving a problem like this, you're going to be given the molecular mass and either percentages or mass of a sample or something to where you can figure that stuff out. So one, we need the approximate. So we need the approximate molecular weight slash mass and the empirical formula. So we need some stuff. You don't really need the empirical formula. You could also have percent composition, but to actually figure out the conversion, these are the things we're going to need. So we're going to go over a few example problems after I show you the basic idea of this. And you're going to have a few different avenues of solving these depending on what you're given. Alright, so for instance, let's say I'm going to just give the molecular formula of this. We're going to pretend like we solved it. And then so we know that right now we're just going to use the same stuff. We have C6H12O6. So say we weren't given this. We were given a molecular weight. We were given a molar mass. That molar mass is going to be approximately 180 grams per mole. I'm just rounding all the values. Alright, so looking at our empirical formula, let's pretend that we don't have the molecular formula. Like, we're just going to ignore this. We have this. We know that we're given an empirical formula of CH2O. So what we need to solve this is we need a molar mass and an empirical mass. So we're going to get not molar. Sorry. We're going to get a molecular ratio. I don't know if there's like a proper term for this. It's just what I call it. So what you're going to need is the molar mass of your compound divided by the empirical mass. Alright, so these are the things we're going to need. So we have a molar mass. We don't have an empirical mass, but we have an empirical formula, so we can figure it out. So we have 1 times 12 plus 2 times 1 plus 1 times 16. So when I add these together, I have 14 plus 16. That's going to be 30 grams per mole. All right, so we're going to take these two numbers, and we're going to plug it into this formula and see what our ratio is. So we have 180, and yes, I should be putting the units, but just to save time, I'm not going to. We have 180 divided by 30, and that's going to give us a ratio of 6. I should probably make that the same color as the molecular ratio, but that's gonna give us a ratio of 6. So now we have our molecular ratio times our empirical formula. This is going to give us our molecular formula. So this is the basic idea. I'm going to walk you through this again. So usually you're going to have a molar mass and an empirical formula, or some way of calculating the empirical formula for some problem like this. So, empirical mass. So you're going to need, you'll have one of those three things in the problem. It just depends on how complex it's intended to be and what you're being asked. You're going to take your molar mass, divide your empirical mass, usually you're going to have to solve for this, into this number. That's going to give you some sort of ratio. What's going to happen is that ratio times your empirical formula, since it is the simplest whole number ratio of this, is going to give you your molecular formula. So watch. We have 6 times, and I want to say that was CH2O. That's going to be C6H12O6, which is the molecular formula. So that would be your answer. So if you need a second to copy this, just take a second, pause the video. So I'm going to go on to some examples to see how you would use this. So we're gonna talk about possibly solving for our empirical formula again, just to kind of review it. Sorry, my dog's barking. So all right, so a major textile company created a new dye. I found this problem online and I actually really liked it. Created a new dye. The dye has a percent composition of, let's say it was 70. I'm going to color code all this again for at least this problem. 75.95% carbon, 17.72% nitrogen, and 6.33% hydrogen. It has a molar mass of approximately 240 grams per mole. What is the molecular formula? So we're going to just pretend that we're going to convert all these to grams because it's out of 100%. So we have 70, I'm going to label everything. Let's do it like this: carbon, nitrogen, hydrogen. So if you remember, we're going to need to find a ratio. That's the percent comp, or the mass, divided by the molar mass of the element. So we have to find a ratio because we have to find the empirical formula first. We don't even have that. So we have 75.95 grams of this, 17.72 grams of nitrogen, and 6.33 grams of hydrogen. The molecular mass, I'm going to just use 12.01 grams per mole. This one is 14 grams per mole. And this one is 1.008 grams per mole. So we're going to need a calculator to go through all this real quick. Alright, so we have, let me clear all this out. 75, not that, 0.95 divided by 12.01. That's going to be about 6.3 or whatever. 17.72 divided by 14, be a little over 1, so like 1.3 or something like that. And 6.33 divided by 1.008, it's about 6.28, whatever. It's not going to make that big of a difference. So we're going to do 6.3, 1.3, 6.3. So now that we have a ratio, we have to divide each of these by the lowest number, which is 1.3. So it's about 4.8, it's about 5. Let's see, if I use the actual numbers, probably be a little bit better. So we have 6.33 divided by 1.27. It'll be a little closer, but it's about 5. But anyways, so we have 5 and 5, and this is 1. So looking at this, we're going to have an empirical formula of CH, or C5H5N. Alright, so now, looking at this, we have to find out its empirical formula. So you have 5 times 12. I'm going to just, instead of rounding, I'm going to just round it instead of using the actual values, just easier. And this one is, alright, so you have 60 plus 5 plus 14, so it's going to be 74 equals 79 grams per mole. Alright, so now that we have an empirical formula and our empirical mass, we also have our molar mass. So let's find out what the ratio is for this. So we have 240 divided by, let me label this too. So we have ratio equals 240 divided by 79. That's going to be very close to 3. We're just going to round it to 3. If you want to see it in the calculator, it's like 3 point something divided by 79. 3.03. We're just going to round it to 3. So we're going to take this number and multiply it by our empirical formula, C5H5N. And then our final answer is going to be C15H15N3. And this is our final answer. I have one more example to show you. I like showing this next example because it's going to involve some fractions. So we're going to have to use a little bit more of a critical thinking to solve this one. Because remember, your empirical formula has to be the lowest whole number ratio. And remember that whole number part, that's important. So this is going to be our example. So determine the empirical, I'm going to write all this stuff down that we need. I'm just writing down the question. Determine the empirical and molecular formula. Molecular formulas for versatile asbestos. It has the following percent comps. Following percent compositions and a molar mass of 520.8 grams per mole. Alright, so I'm going to write the percent compositions underneath. I'm going to just do it vertically since it's easier for me to represent it. So we have magnesium, silicone, hydrogen, and oxygen. So I'm going to do like some vertical columns here. Alright, so we have our percent comp. It's going to be 28.03 grams. This one is 21.60 grams. This is 1.16 grams, and this is 49.21 grams. Alright, so our molar masses for each of these. Magnesium is going to be 24.305 grams per mole. That's a little tight there, but that's fine. This one is going to be 28.09 grams per mole. This is 1.008 grams per mole, and this is 16 grams per mole. Alright, so we're just going to plug all these into the calculator, and we'll get how many moles we have underneath. By this point in your chemistry class, I'm kind of assuming that you know how to do the dimensional analysis, so I'm just going through and doing this. But anyways, you have 28.03 divided by 24.305. That's going to give us about 1.15. 21.6 divided by 28.09. That's going to give us about 0.77. So we have 1.16 divided by 1.008, about 1.15, and then this one was 49.21 divided by 16, and that's going to be about 3.08. So let's write all those down. So we have 1.15, 0.77, 1.15, and 3.08. So now that we have our molar ratios, these are the moles that we have from the sample analysis, we have to divide all of these by the lowest number, which is 0.77. Alright, so looking at these, I know that this is going to be 1. Those look like they're about 2, but I don't know off the top of my head. Actually, they're a little less than 2. So we have 1.15 divided by 0.77. Yeah, it's about 1.5. And then we have 3.08 divided by 0.77. That's the only other one I gotta do. Oh, that's 4 exactly. Cool. So 4, this is 1.5, 1.5. So take a second. Let's write the empirical formula down. Take a second and ask yourself if you think this answer would fly. Alright, so I'm assuming you just came back from pausing it. The answer would not be valid. We can't have half of an atom when we're talking about a compound. So it's got to be a lowest whole number ratio. If you don't know, 1.5 is equal to 3 divided by 2. I always like writing these as fractions just because it's easier to see what you have to do to get rid of the that partial number. So looking at this, remember, if I just multiply all of this by the denominator, I'm going to get rid of it. So this cancels out these. But you have to distribute it to here, here, and here. So I'm going to get rid of that. So our final answer for the empirical formula, this is the first part, is going to be Mg3, Si2, H3O8. So this is our empirical formula. Alright, we're not done. If you remember, we had a molar mass. So we found the first part, we found the empirical formula, but we had a molar mass of 520.8 grams per mole. That's what the compound actually weighs. Let's see what this one is. So looking this up, we have 24.305 times 3 plus, let me look up, 28 times 2 plus 1.008 times 3 plus 16 times 8. I am going to just do this in the calculator. It's way easier. So let me move this over here. Alright, so we have 24 point, actually just use parentheses, it's easier. 24.305 times 3 plus 28.09 times 2 plus 1.008 times 3 plus 16 times 8. So this is going to come out to about 260.1. Alright, so if you think you know what to do to solve for the actual molecular formula, pause the video and go ahead and do it. Alright, so we need to find the ratio. So that's going to be, what we're doing is we're going to divide the molar mass of the compound by our empirical weight, which is 260.1 grams per mole. If you just ignore this, it's going to be super close, but if you just ignore the decimal points, this clearly is going to be 2. And I'm going to show you in the calculator. Like a lot of times you can just kind of ignore it and do it in your head. 0.8 divided by 260.1. And very easily we know that this ratio is 2. So we're going to take this ratio and multiply it by our empirical. Alright, it's a horrible 8. Alright, so we're going to distribute everything. So our final answer is going to be Mg6, Si4, H6, O16. And this would be your final answer right here. So I hope that helped you if you were kind of struggling with how all this was interconnected and how to kind of solve these problems. But really, if you just follow the basic steps for doing this, you should have a good grasp on how to solve these problems. So with that being said, I will see everybody in the next video.